Let's calculate the slope of the curve. F of x equals x squared minus 3x plus 5 at any point x equals a. What we're looking for is the derivative, which will tell us the instantaneous rate of change. We start this with a limit definition of the derivative x equals a. Remember that here h is the tiny change in x. We are going in order, so the first thing we need to do by looking at the definition is that we want to get the first part, f of a equals h. So our second step is to plug in the function. And all we have to do is to substitute the a plus h with the x in the parentheses. This is not 100% done, so let's expand a plus h squared. Factoring binomials is commonly used in calculus. To simplify your work, it helps to recognize common patterns in binomials, such as the difference of squares or perfect squares. In this case, we square the first term, square the last term, and the middle comes from multiplying the two terms together, and then double it because each term multiplies the other. We continue to expand the next part of the equation. Now we can put the two parts of the equation back together, and we also write down the plus 5 at the end. And we have completed the first part of the definition. Now let's move on to the next part. So the next thing in the definition is to subtract f of a. So we take the original equation and just substitute with a, and we have the top part of the definition, which we can now subtract. So notice that this part is from step 1, and just as in the definition, we apply the minus, and distributing it looks like this. The a squares cancel each other out, as well as the 3a and the 5's, and this is a result for the numerator part. Now the next step is to divide by h. We plug in the result for the numerator and divide by h. Most of them cancel themselves out, and we are left with this equation. And for the final step, we take the limit as h approaches 0, where the remaining h approaches 0, and we get our final result for this problem, which is also the derivative.